I'm going to share some time with you on the geospatial platform and some new technologies that are having us at Bentley really excited about the kinds of enablements that are going to be possible. Just a few statements about the company. Bentley is about 30 plus years old, and we're exclusively focused on advancing infrastructure software solutions. And of course, we believe that the higher the quality of the infrastructure, the higher the quality of our lives. And of course, it reminds us being here in Rotterdam, as our colleague told us when he introduced us today, the show, if there was no infrastructure, we would be perhaps 6 meters of water above all of us. I think 90% of Rotterdam is below sea level. So we would be not standing, we would be needing snorkels or something if it wasn't for infrastructure here. And that's what we do, that's what we focus on. And the reason why, after all these years in the business, we're so excited about the geospatial platform is basically around convergence of a few things, not the least of which is the billions of dollars of investment in consumerization. Every one of us walking around with these consumer devices that have sensors in them, that have GPS in them, that have accelerometers in them, have led to so much of development that those of us in the professional industry can leverage and produce what we call reality modeling, which I'll speak about in my 10 or 15 minutes. But the convergence to us is around having a vision that every piece of physical infrastructure will have and can have a digital equivalent of it, what we call digital engineering models. Because at the end of the day, even though we have wonderful infrastructure in the developed world, it's very expensive to maintain it. It's very expensive to enhance it. And of course, in the developing world, they need a lot more infrastructure. And globally, there is a huge deficit between what we can afford and what we need. And technology can help bridge that gap through the ability of what we call reality modeling. So what is reality modeling? It's fundamentally three things, because if you imagine a lot of the built infrastructure today does not have a digital equivalent. And if you have a digital equivalent, I can guarantee you that it's not up to date. You do not have something that reflects reality. There was your as-designed reality, there's your as-constructed reality, and there's your as-operated reality. And the other thing about infrastructure is every one of them is somewhere on the planet. And therefore, geospatial elements are fundamental to all of these pieces of infrastructure. So whether you're talking about planning, whether you're talking about construction, whether you're talking about operations, for us, we believe that what we call a reality modeling platform can provide you that context no matter where you are in the entire process. So let me talk about what we call these reality meshes, which are digital models of physical reality. What are they? And how do we leverage them in our daily lives beyond just the 2D maps that you perhaps every one of us uses on a GPS or other types of queries that you do over the web. These are fundamentally tractable elements of capturing reality effectively so we can use them in our tools as engineering professionals every day. And let me just show you a quick video of how such reality modeling is possible. Number one, you start with acquisition. I talk about all of these consumer devices that let you capture information really, really quickly, really, really easily. In this case, just taking photographs. Of course, we're all used to sophisticated LiDAR devices, going out there, flying planes. That consumerization with drones, it's actually painful. You go for a picnic in a park and these people are flying drones everywhere. And this is what's possible then. You can create physical models in a computer of substations. How many million substations are there in the world? how many of them actually have a digital model of that substation that then you can use? Here, we captured that through a couple of hundred photographs, and now we can use that model in context in an engineering tool to be able to then retrofit it, and be able to then expand it, create 3D models from it. And all it took was throwing up a drone, spinning it around, of course, and some magic has to happen to do some registration and then interpolate from all of that. You can also, in context, take all of that reality mesh data and do a whole lot of what if scenarios of how will it look if I put in a new building here. And I can do some simulation with that context, with lighting, with some views. What exactly will I see when I stand at this location? I can put in some traffic. And all of this is possible by compressing the amount of time it would take for us to go out and capture the data of what's there physically. You can imagine the amount of savings that can happen in your upstream data collection process because of such technology. And the other cool thing, now this is what's going to happen if the dikes fail, right? So we'll be figuring out how to deal with flooding and all sorts of natural disaster simulations. And of course, the other wonderful thing is, with all of this technology, everybody today is wanting to view it on their desktops, on their devices, over the web, tractably streaming huge amounts of this information through standard formats like WebGL is absolutely feasible. Beyond all of those things, we can see that at the end of the day, what you've got here is not gigabytes worth of point cloud information. You've got mesh information, which is a lot more compact. It's fairly easily manageable in terms of its layers, turning them on, turning them off, being able to really distill down to the core amount of information that you need. Now, there's a city scale of such geospatial platforms, and then you can think about it in every possible scale. In this particular case, you've got scenarios where you're trying to create some inspection-based orientation, or in the case of coal plants, where you've got to retrofit carbon scrubbing devices, and none of these plants have any models. You don't know where to start. Think about the expense in it. Here you can go out, build a reality model, build these meshes, create a whole host of scenarios that can very cost effectively and very cheaply allow you to explore different alternatives for your designs. And in the case of inspections, think about all of these plants across all of your assets and being able to effectively inspect them. One of my colleagues here, Senior Vice President Ted Lambu, is going to be talking on Wednesday about continuous surveying. Think about construction sites. What happened yesterday? Bringing in the time element into all of your geospatial platform data. And once you have that temporal element in all this information, you can do all sorts of degradation analysis, showing the cracks, how it's progressing, being able to then effectively decide what you should be doing at what time. In the case of natural disasters, being able to quickly, easily, efficiently give the amount of damage that occurred on this particular site. And then, since the result of this capture is not billions of points, it's actually finite, compact engineering precision data, you can do lots of manipulation using professional tools to be able to extract features effectively and then use a lot of engineering trade-off analysis on the basis of it. All of this stuff was, I would say, even maybe 4 or 5 years ago, not possible. I would say even 2 years ago, I don't think I could be standing here telling you such things are capable because of the convergence that's happening between consumerization, between cloud computing, between all of these different things happening together is what's making all of this possible. I'd like to perhaps give you another quick example of this in the context of a real-world project, if you will. The Pope visited, I'm from Philadelphia, and for those of you who may remember, September last year, the Pope visited the US. And a lot of us in Philadelphia decided to leave when he was going to be there because of the crazy traffic. But what was interesting was our CEO, Greg Bentley, offered to see if we could take all of this technology and leverage it in a real-world project of planning the Pope's visit. Because usually the security, there was a Secret Service, there was a lot of planning, and usually they do everything on 2D maps. We said, what if we could do this in 3D? Actually build a city model of the entire area that the Pope was going to visit and be able to then use that as context to plan his trip. And that is exactly what we did. So none of this existed before. They took information from the ground. So they first started with, this is where the 2D map was going to be, and this is where the World Family event was going to be held. And we said, let's capture all this information. We had volunteers from the company working with the city, working with the Secret Service, capturing all the data with our ProjectWise, and they were modeling the security barricades actually in almost a 3D context, where none of this was something that they were ever used to before. It was quite amazing. And the end result was a pretty spectacular reality model, if you will, that they could then use to even figure out, depending on the weather, what exact views would you be able to see if the Secret Service was in a given location on the 17th floor of a given building, what sort of views would they see? They could model different weather patterns and automatically just figure out what sort of changes you could imagine. And you can think about now, in July, there's going to be the Democratic National Convention in Philadelphia, and none of this information is wasted because everything we can do, we can build on what we've got, take a few more photographs, augment this information, and build from it. It's pretty spectacular. So this is actually the end result of what was done with all this information. And at the end of the day, I think that you could imagine this. In this case, there were about 28,000 photographs or so with one mesh. But to us, this technology platform can enable a whole lot of new business opportunities, redefining how information is captured upstream, redefine how this information can be used during engineering, redefine how this information can be used during construction with continuous surveying and knowing exactly what happened from a day-to-day basis, reimagine how all of this information can be used in natural disasters that happen all the time, reimagine how this information can be used in operations. These assets are used for decades, and we're just not at the imagination stage to imagine that with sensors and all this infrastructure in a real-world context. So your models on your computer will be the interface to these physical assets through exactly the same cognitive workflow. You won't be looking at a dashboard of numbers. You'll be looking at the view of the physical piece of infrastructure. And that is something that we can all really imagine presenting to the next generation of kids that are growing up in video games that think that's just so natural. They just don't understand it. It's pretty hard to do, right? So, and the technology is so amazing, it can be used to even capture interiors. So if you think about it, we could have a digital model of this World Trade Center with no engineering drawings to begin with in a matter of weeks, to the accuracy of millimeters, if we chose we needed to do that. And then you overlay that with all the wiring system, with all the sensors, and it's just amazing as to what we think is possible. Now, I'll leave you with this one final video that is showing all of the same technology, but in the context of conceptual design. Being able to now also use this geospatial platform to do efficient trade-off analysis when you want to design new pieces of infrastructure. So you can imagine that Today, if engineers are working, they're just grateful to get one design done in the time allotted within the amount of money and budgets they have. Because the amount of work that they do relies on not knowing whether they had anything about the real world. In this particular case, we are wanting to extend out some new conceptual designs to add some new roads in an existing city. You don't make any assumptions of what you had. You can quickly, easily capture this data, and then you can, almost as a video game, start playing some analysis of cost. So you can do trade-off analysis of how much cut and fill, what's the best optimized alignment, and you're doing all of this in a conceptual design phase where such notional space-time elements were completely unfeasible to imagine doing this even, I'd say, 6 months to a year ago, because this technology is being inherited from consumerization, from movies. You know, we got this technology that all you see, the Avatar movies where they're modeling, all of that Hollywood technology is being used, all of the consumer technology is being used. So all this entire geospatial platform is possible because of this convergence. So we believe that because of this, it enables a lot more value propositions. So Sanjay, as to where the money is, we're leveraging the billions of dollars of R&D spend that's happened across all these different industries, bringing it to the infrastructure industry, and then enabling a whole set of new workflows where we think is going to redefine and reimagine and enable us to close this infrastructure gap.